This is a quick brief on microwave observed winds from the AMSR-2 instrument on GCOM. I'm Scott Lindstrom from SIMS. AMSR-2 is the Advanced Microwave Scanning Radiometer 2 on the GCOM satellite that was launched by Japan's JAXA. GCOM stands for Global Change Observation Mission and is also known in Japan as Shizuku. This quick brief will tell you how the winds are produced, how they can be used, and where you can find them. Winds over water excite small waves and generate foam that affect the emissivity in the microwave. These differences are detected by the satellite and winds are inferred. JAXA is the Japan Space Agency, roughly the equivalent of NASA in the United States, and it flies two GCOM instruments. The one producing AMSR-2 winds was launched in 2012. This list defines the bounds of the wind observations. Here are observations over the Great Lakes. Note on the left how the signal is present even with clouds, because the microwave signal is largely unaffected by clouds. Lakes Ontario and Erie are large enough that there are small regions mid-lake that are 25 kilometers from land. The other Great Lakes have larger regions where useful observations can be gleaned. Small day-to-day variability in where the data appear depends on exactly where the orbit is with respect to the lakes. Why are these winds important? Some reasons are listed here. The biggest is that this is a data source in a region that is otherwise void of data. Note in the figure missing data, underneath strong convection, as inferred from the inset infrared image. Very heavy rains will absorb the microwave signal from the sea surface. Don't expect to see winds with tropical convection, for example. You'll get peripheral winds, but not winds in the rain bands themselves. Strong winds in one region, here over the Northwest Atlantic, can generate strong waves that can propagate across the basin. The waves generated in this image showed up several days later in Tenerife, causing damage. Altimetric data from JASON, for example, could have been used to trace the wave action across the Atlantic basin. Data can be found online at the links shown. There's also a link to general information about AMSR-2 on GCOM. Here's what the data looks like at those two links. AMSR-2 does give global coverage, with some gaps at the equator. Here are some concluding thoughts. Thanks for listening.